So you know what we're doing. We know we're doing connector and assignment problems. Now, I did tell you yesterday that if you weren't here, then catch up quickly. We're starting 9B, and yesterday I just revised for you very quickly the whole business of matching a directed graph, as on the left of your diagram, with the matrix on the right. And if you're given the graph, you can produce the matrix, and if you're given the matrix, you can produce the graph, right? Yep, done all that. Well, first two questions, of the exercise are just doing that. Then we introduced what this exercise is really about, which is matching one set of things to another set of things and doing it in the cheapest and most optimum way. So it could be people to jobs, as I was telling Cameron just earlier, kids to ice creams, assigning teachers to classes. There's some cost involved, and you've got to do it the cheapest way possible. Now, there's two ways of doing this. There's the easy way, or the simple way, which is called bipartite graphs, and we've also looked at those already. And after I've just gone past that, we'll have a look at our first look at the cost matrices, which is the complicated thing. So bipartite graph was one of them. So you've got 5 people. So in the matrix, that'll be the rows, and you've got 5 jobs, that'll be the columns. And very quickly, we worked out that things like Angie has only got one thing that she could be applied to, which is Senegal, because she doesn't know anything about it. So we have to actually choose that one, to do that properly. And I'm not going to go through it all again, but things like, this is the simple way of doing it. If Angie goes to Senegal, then Dorian can't go to Senegal. It's that kind of process where you eliminate people and you select people that's going to decide who is going to do what. And without finishing it off, because we did it yesterday, you're going to finish up with that, which in then turn finishes up as that. So we made the assignments. Now, that thing that I talked about there is comes in again at the end of the cost matrix problem. So you're going to need that at the end of what I'm going to teach you now. So yes, we're going to be learning language. How many have you got? Now, so that's where the complication comes in. We've got 4 people and 4 jobs and 4 allocations to make, but there's a cost involved. For Wendy to do job A is going to cost 30 units of something. If she does job B, 40, job C, 50, job D, 60. Now, you can't just use the bipartite graph directly to apply that because the cost is involved, and as you'll see. So, as it says at the bottom, it's too complicated for a bipartite graph yet, especially when weighted 2. What we've got to do is reduce that information that's in that matrix to the point where you can make a bipartite graph. That's what we've got to do. We've got to get rid of some of those numbers. Now, this is in the textbook, so you could follow it in the textbook if you like. But that's the first example that they've got. Down here is where I'm going to be writing the instructions at each stage. You copy them down if you like, or just wait till the end. The instructions are all going to be on one screen, but there's about 6 steps involved in reducing this to a bipartite graph. You won't remember the whole thing the first time through. It took me 3 or 4 times to get it, but I've got it now. You've got to remember it long enough to do an exam on it. So that's the problem. Now, the first step, all right, here's the instructions. In each row, you find, not what Natalie says, but you find the lowest value, and you subtract that from all the values in that row. So can you see Wendy's smallest number is 30? What we're going to do is get as many zeros in this matrix as we can, not the way that you want to do it, but this way. All right, well, can you just concentrate on this first? Wendy's smallest number is 30, so if we take away 30 from Wendy, that's 0, that'll be 10, that'll be 20, and that'll be 30, agreed? And if you look at Xenophon, he's got also his smallest score is 30. So this is going to be 40, 0, 10, 40. And dumping down to Zelda, smallest score is 20, so 0, 60, 30, 40. All right, that's the first step. And you always do that. You take the smallest number from the rows. And because I've done all this, that's what you just read out to me, or I just read out, we read out together. Okay, so that's the first step. In each row, find the lowest value, and that's what we've just done. Now, here comes the second step. We've got to get rid of more zeros than that. It's difficult to explain why this works, but it just does work. I'd like to find out why it works myself, but it's probably a complicated answer which won't help very much. But we've got to get rid of more zeros. I can't really tell you why I can't make the allocations yet. So the next step, it says, draw as few lines as possible, horizontal or vertical, to cover the zeros. Now, what it doesn't say on this one, but it will on the next one, is we're making 4 allocations, so we've got to get to the point where we have to draw 4 lines. If there was 5 people, we'd have to draw 5 lines. Now, can you cover those zeros with less than 4 lines? Now, what I mean by that is, that's covered 2 of them up. Yeah. That's covered now 3 of them. I'm covering zeros, all right? And there's another 0. Now, I've done all the zeros with only 3 lines. We've got to get to the point where it takes 4 lines. And if you can try a way, there's other ways of doing it, but you cannot, I think, sorry, I've got 3 lines, so that proves that you haven't got 4 lines. That's the point. Once I've covered all the zeros up, okay, then if I've only taken 3 lines, I've got to carry on with the next step. So let's have a look at that. That's a different way of doing it. That's a different way of doing it, but it's the same thing. It still only took 3 lines, yeah? So we've got to do the next step. The next step is to look at the table and say, so get rid of those lines. You've got to draw all this again, get rid of those lines, say, are there any columns with no zeros? That's one of the things we've got to achieve. All those columns have got to have a 0 in them. Well, there's this one here. That's got a 0 in it, that's got a 0 in it, that's got a 0 in it. That's what you could cross about by just doing all columns, if you like. If there is, look at the smallest value, which is 10, and take it away from each of those numbers. So this is going to be 10, 20, and 20. All right, so that's your next step. Now, I know you don't have to remember these steps. I'm just telling you you're going to have to go through them. There you are. 0, 10, 0, 20, 20 in there, okay? So that's the next step. Now we've got to try and draw lines again. Draw as few lines as possible, horizontal or vertical, to cover the zeros. Now, it doesn't matter whether they're horizontal or vertical. All right, so that's got rid of 2 of them. That's got rid of 2 more of them. But I only need 1 more line, horizontal or vertical. Still only taking 3 lines. You've got to use as few lines as possible until you are forced to use 4, in which case you've got to the end of the problem. All right? So we've got to continue. We haven't got to the end point where we can allocate yet. That's one way of drawing it. I drew it another way. This is basically the last step. We've got to continue. This stage says, find the smallest uncovered value. We've crossed out, there's our 3 lines. There's the smallest value is 10. There's a 20 there, 20 there, 60 and 20. This is a 2-stage one. Once we've found the smallest value is 10, we add it to each cell that's covered by 2 lines. And this is really weird, this. So that's covered by 2 lines. Yeah? That's covered by 2 lines. So we're going to add 10 to each of those. So we're going to have a 50 and a 50 there. And we subtract 10 from all the uncovered values. So this is going to create more zeros. That's going to be 0, 0, 10, 10, 50, 10. So not much more to concentrate on now. There you go. 0. So this has gone up. That's gone up to 50. That's gone up to 50. And all the others have come down. And we've got more zeros now. Now can we draw? Do we have to use 4 lines to cover it up? 3rd time, lucky. Well, there's 1 line. There's another line. Let's taken off 2 of them. I can't get these 2, can I, at the same time? So 3 lines, 4 lines. You've got to the point where you're going to have to use 4 lines So you finished eliminating. We can now do a bipartite graph and assign them, which you'll see next. So I've got all these slides up here. There you are, 4 lines. Now we can make assignments. So Wendy, Xenophon, Yolanda, Zelda. There they go. A, B, C, D. You assign where there's a 0. Wendy 0 goes to A. Wendy 0B, she can go to B and C. Xenophon can go to B and C. Yolanda can go to D only. Zelda can go to A only. Now remember what we did before at this stage, right? Can you tell me anything that has to happen? Only Zelda can go there, right? Only Zelda can go to there. Cameron's making all the contributions and he wasn't even here yesterday. So Wendy can't go to A now because that one's there. Another one? Yolanda has to go to D. No question about that. So now here, in this particular matrix, there's nothing else you can eliminate by using all that kind of thinking. But if you can't eliminate by that kind of thinking, you just eliminate anyway. It doesn't matter what you do. So there's no more eliminations you can make. Either of those is possible. So just say Wendy to B and get rid of that one, which means Xenophon goes to, so that cut doesn't go there, so Xenophon goes to C. And you're going to write down Wendy to B, Xenophon to C, Yolanda to D, and Zelda to A. Now, that's the bipartite. There's one more thing to do, sorry, but we've got to give a value and add up the values, and this is going to be the minimum cost. Now, the values are not here. The values are on the original matrix, which I haven't got on the screen, but I have got it there. Oh, I've got to do it again now. Whatever the original number was. Wendy was going to, that's A, that's there, and it doesn't matter what we do there, does it? So Wendy to B is 40. Wendy to B equals 40. Xenophon to C is 40. Yolanda to D is 30. Zelda to A is 20. 40, 80, 110, 130. That is the assignment and that is the cost. 130. So, you got all that? Now, those are the instructions which I just gave you, bit by bit. So step 1, in each row, find the lowest value and take it off. Step 2, draw as few lines as possible. Step 3, any columns with no zeros, reduce that column. Draw the lines again. Determine the smallest uncovered value, add it to all the ones covered by 2 lines and subtract it from all the uncovered ones. I know you can't remember what I'm saying, but I'm just running through it. Draw the lines again. We've made our 4 allocations, and you calculate the minimum cost. And that's what it's all about. That's the Hungarian algorithm, and that's the worked example.